Hi friends, welcome back to our YouTube channel, One and Only Pharmacy. So friends, in today's video, we see lectures about chapter site separation, subject pharmaceutics, D pharmacy first year. Also, this involved in B pharmacy, pharmaceutical engineering. So friends, please watch this video till the end. Let's see what we see in today's lecture. Content about this topic: site separation. What is site separation? Its objectives, official standards of powder. Sieve, what is sieve? Mechanism of size separation. Sieve shaker machine, cyclone separator, air separator, illustration tank and bag filter. So friends, please watch this video till the end. Let's start one by one. Size separation. Size separation is a unit operation. What is size is separation is a unit operation that involves the separation of a mixture of various size particles into two or more portions by means of screening surface. Size separation is also known as sieving, sifting, screening. Size separation is also known as a sieving, sifting, and screening. This technique is based on physical differences between the particles such as size, shape, and density. Friends, in simple language, I say size separation means separate out the different types of particles. मतलब some particles are large in size and their shape, and some are in small in their shape. According to sieve, a screening surface, we different or we sort out the particles according to their size are called as size separation. In their name, size means according to size. Separation means a separation form. Large particles, small particles, etc. are also known as a sieving, sifting, and screening. Let's see next point. Objectives and applications of separation. Why we do size separation and what's their applications or objectives? There are six objectives or applications of size separation. To determine particle size for the production of tablets and capsules. First objective, to determine particle size for the production of tablets and capsule, because sometimes tablets required another size and capsule required another size. For that purpose we separate out the particle size. Second objective, to improve mixing of powders. If uniformity in size, then mixing is very easy. If particle does not unique size, then mixing is not unique. Third, to improve the solubility and stability of particles during production. For solubility and stability purposes, we produce size separation. Fourth objectives, to optimize feed rate, agitation, screening during production. Fourth, fifth, quality control of raw materials. For obtaining a quality or check the quality control of raw materials, we do the size separation. And last objectives, useful in production of tablets, capsules, suspensions, emulsions, ophthalmic preparations, ointment, creams, and etc. I say first, I say you first. According to size or dosage form, there are every dosage form requires there are different sizes. Ointment requires another size. Ophthalmic requires another size. Tablets required another size, and cream, मतलब कि topicals agents required another size. For that purposes, we require size separation. Second point, official standards for powders. There are 5 standards of powder, namely coarse powder, moderately fine powder, and very low fine powder. In exam, ask this type of question. Write the official standards for powders. Means types of powders according to their sizes. The Indian Pharmacopoeia has laid down the standards for powders for pharmaceutical purposes. The IP specifies 5 grades of powder, which are as under: coarse powder, coarse powder, fine powder, very low fine powder, etc. See, first coarse powder, a powder of which all the particles pass through a sieve with a nominal mesh aperture of 1.7 mm, that means number 107, and not more than 40% through a sieve with nominal mesh aperture 355 micrometer, number 44 sieve is called as coarse powder. There, according to type of sieve or how many drugs per powder particles are passed through which sieve we classify powders in their grades. In coarse powder, not more than 40% in number 40 sieve and not or completely pass through number 10 sieve comes under the coarse powder. Moderately coarse powder, a powder of which all particles pass through a sieve with nominal mesh aperture 710 micrometer number 22 sieve and not more than 40% through a sieve with a nominal mesh aperture of 250 micrometer number 60 sieve is called as a moderately coarse powder. Coarse powder means highest size of powder. Moderately means moderately coarse मतलब less than coarse powder. And third, let's see third grades of powder. Moderately fine powder. If all the particles of powder pass through a sieve with a nominal mesh aperture 355 micrometer, that means number 44 sieve, and not more than 40% through a sieve with nominal mesh aperture 180 micrometer, number 85 sieve, it falls this group. It comes under the moderately fine powder. Fourth one, fine powder. In case all the particles pass through a sieve with a nominal mesh aperture 180 micrometer means number 85 sieve, it's called as fine powder. Fine powder means all particles pass through a sieve number 85. And next, fifth grade very fine powder. If all the particles of the powder pass through a sieve with a nominal mesh aperture 125 micrometer, that means number 120 sieve, it is said to be very fine powder. Here sieve number increases and particle size is decreases, that means they are opposite. If sieve number is large, that means 100, 80, 120, then these are the very fine particles. Let's see here, fine powder means number 85 sieve and very fine powder means number 120 sieve. They are opposite to each other. These are the five grades of powder: coarse powder, moderately coarse powder, moderately fine powder, and very fine powder. Let's see what is sieve. Sieve. Sieves means what is sieves? Sieves are constructed from wire cloth with a square meshes woven from wires of brass, bronze, stainless steel, or any other suitable material. The wires should be of uniform circular cross section and should not be coated or plated. There should not be any reaction between the material of the sieve and the substance which is being sifted from it. Sieves in a simple language, I say sifting like a chimney. That means sieves. There are different types of sieves according to their sizes. Standards for sieves used to testing must specify the following: number of sieves. Sieves number indicates the number of meshes in a length of 2.54 cm in each transverse direction parallel to the wires. In exam, ask this question: what is number of sieve? What is nominal size of aperture, etc. Or give the standards of sieves. Number of sieves means sieves number indicates the number of meshes in a length of 2.54 cm. Here is note down 2.54 cm in each transverse direction parallel to the wires. Second standard, nominal size of aperture. A nominal size of aperture indicates the distance between the wires. Nominal size of aperture indicates the distance between the wires. It represents the length of the side of the square aperture. The IP has given the nominal mesh aperture size for majority of sieves in mm or in centimeter. Here see what is sieves, and nominal size of aperture means in square. Sieves, everyone knows sieves. There are different types of sieves according to their mesh sizes. Nominal diameter of wire. Wire mesh sieves are made from the wire having the specified diameter in order to give a suitable aperture size and sufficient strength to avoid distortion of the sieve. These are third standard. Fourth, approximate percentage sieving area. This standard expresses the area of the meshes, a percentage of the total area of the sieve. It depends on the size of the wire used for any particular sieve number. Generally, the sieving area is kept within the range of 35 to 40% in order to give a suitable strength of the sieve. These are the approximate percentage sieving area. Fifth standard, tolerance average aperture size. Some variation in the aperture size is unavoidable. Some variation in the aperture size is unavoidable, and when this variation is expressed as a percentage, it is known as the aperture tolerance average. These are the standards or of mesh or sieves. Mechanism of size separation. How size separation is done? There are three mechanisms. The working of mechanical sieving devices are based on any of the following methods. That means every device are based on the either agitation, either brushing, or either centrifugal forces. These are the type of mechanisms. Let's see one by one. What is agitation? Agitation methods. Under agitation means sieves may be agitated in a number of different ways, such as oscillation, vibration, and gyration. Let's see what's oscillation. The sieve is mounted in a frame that oscillates back and forth. It is a simple method, but the material may roll on the surface of the sieve. Oscillation means like spring, forth back. Our product is separate out. Vibration means vibrate. The sieve is vibrated at a high speed by means of an electric device. The rapid vibration is imparted to the particles on the sieve, which helps to pass the powder material through it. These are the second agitation methods. Third, gyration. In this method, a system is made so that sieve is on rubber mounting and connected to an eccentric flywheel. This gives a rotary moment of small amplitude to sieve, which turn gives spinning motion to the particles that helps to pass them through a sieve. These are the gyration. Let's see, agitation means a sieve attached to the electric device and forth and back sieve is movement. According to movement of sieves, our particles are separate out according to their sizes or according to mesh sizes, oscillation, vibration, etc. Agitation methods are not continuous methods but can be made so by inclination of the sieve and the provisions of separate outlets for undersized and oversized particles. Brushing methods. In this case, a brush is used to move the particles on the surface of the sieve and to keep the meshes clear. The brush is rotated in the middle in the case of a circular sieve, but spiral brush is rotated on the longitudinal axis in case of a horizontal cylindrical sieve. In brushing methods, what brush is main character. According to our particles are separate out. Centrifugal methods. In this method, a high-speed rotor is fixed inside the vertical cylindrical sieve. In this method, what we do, a cylindrical, a fixed rotor is fixed in a vertical cylindrical sieve, so that on rotation of rotor, the particles are thrown outwards by centrifugal force. The current of air which is produced due to high speed of rotor helps in sieving the powder. In next we see how the centrifugal methods works, brushing methods is done, agitation methods is done. We see some separator like a cyclone separator, air separator. Let's see first sieving method. These are the very important questions asked in general exam. Or write a short note on sieving method. In this method, the fine powder is separated from the coarse powder by using a sieve of desired number. The degree of fineness of a powder is known with the help of a sieve through which the powder material is passed. Sieves are numbered in order to distinguish from each other. Means in these methods, what we do, there are different types of sieves. Sieve size we arrange. Firstly, small size, मतलब कि large number of particles used are in upper side, and in lower side very low size of mesh we use. If you put material in upper side, then according to mesh size, particles is go down, and lastly, very fine particles we get. Let's see how the method is done. Working and construction. Size separation of powder is done by passing the powder material through a set of sieves. That means 8 or 9 sieves we are arranged. Sieves are arranged in descending order. Sieve of larger size is at the top and the smallest one at the bottom. I say you, the smallest size sieve is downward and upper larger size is in upperward. The bottom sieve is attached to the receiving pan. The material is placed in the uppermost sieve. The sieve are shaken with the help of mechanical sieve shaker or electromagnetic devices. It helps the particle to pass through the sieve. I see you. Let's see how it's done. Here is a simple diagram. There are 9 shoes according to their in upper side lead we put in middle shoes of different shoes number, that means in upper side large match size and downward or last in small match size or a receiving pan, indicator bulb, speed regulator, how the particle is we get on the base of speed is we maintain is it is called as a sieve shaker machine. Advantages. What's the advantages of sieving method or sieve shaker method? Inexpensive, that means it's very economical or easy to use. Disadvantage, chances of clogging of sieve if powder is not properly dry. Clogging means agglomerates with each other. During shaking, attrition may occur. That means attrition means our particle is reduce their sizes, means breakdown particles. List second, cyclone separator principle. In cyclone separator, the centrifugal force is used to separate solids from fluids. The separation depends not only on the particle size but also on density of particles. Hence, depending on the fluid velocity, the cyclone separator can be used to separate all types of particles or to remove only coarse particles and allow fine particles to be carried through with the fluid. Cyclone means wind. In cyclone separator, what's the mechanism in all this in all in centrifugal force? With the help of centrifugal force, coarse powder are go down, and with the hair and fine particles are move with the fluid particles. That we on the basis of centrifugal force, we separate out coarse powder and fine powder. Construction. How it construct? It consists of a cylindrical vessel with a conical base. It consists of a cylindrical vessel with a conical base. In the upper part of the vessel is fitted with a tangential inlet and a fluid outlet, and the base is fitted with a solid outlet. Working. The suspension of a solid in gas, usually air, is introduced tangentially at very high velocity so that rotary movement takes place within the vessel. The fluid is removed from a central outlet at the top. The rotary flow within the cyclone separator causes the particles to be acted on by centrifugal force. The solids are thrown out the walls there after it falls to the conical base and discharge out through solid outlet. Uses. What is the uses of cyclone separators? First use, cyclone separators are used to separate the suspension of solids in a gas. It can be used with the liquid suspensions of solids. Let's see here diagram. Cyclone separator, solid outlet, that means coarse powder over downward. In say upper part, fluid outlet, that means fine powder. And this side tangential inlets, we put our material and air, hot air. Here this is the original diagram. A cyclone separator looks like that types. Second, air separator principle. It works on the same principle as that of a cyclone separator, that means centrifugal. But in this case, the air movement is obtained by means of a rotating disc and blades to improve the separation. The stationary plates are used. By controlling these blades and the speed of rotation, it is possible to vary the size at which very separation occurs. Air separator are same as a cyclone separator, but in air separator we use a sharp blades at disc construction. It consists of a cylindrical vessel with a conical base, base as like a cyclone separator. In the upper part of the separator, the vessel is fitted with the feed inlet, and the base there are two outlets, one for light particles and other for heavy particles. The rotating disc and rotating blades are attached to the central shaft to produce air movement. Very simple. The sample powder is passed through the feed inlet. The sample powder is passed through the feed inlet, which falls on the rotating disc. The rotating blades are attached to the same shaft. This produces a current of air as shown by the arrows. The fine particles are picked up and carried into space where air velocity is sufficiently reduced. The fine particles are dropped and ultimately collected on at an outlet meant for fine particles. We see we having both in downward two outlets, one for fine particles and other another is a coarse particles, sorry, heavy particles. The heavy particles which fall downward are removed at an outlet meant for heavy particles. These are very simple working. What are the uses of air separator? Air separator is often attached to the ball mill or hammer mill to separate and return oversized particles for further size reduction. Here is the simple diagram of air separator. Let's say in downward, coarse powder outlet, that means heavy powder outlet. Second, fine particles outlet. In middle, airflow. Secondary fan or blades we attach. Distributor means blades attach. Primary fan. Feed means in upper side we put our material. Let's see here original diagram. That means mechanical, coarse fan, coarse discharge, fine chamber, separating zone, rejector cage, deflector, distribution plate, feed spout, drive shaft, feed spout, air dispensing lowers, air intake, fine air discharge, annular space, and coarse cone. In just exam, we you just remember a right hand side diagram, a mechanical air separator, figure number 2. Second, illustration method. The size separation of powder is based on the low density of fine particles and high density of the coarse particle. Illustrating tank is used to separate the coarse and fine particles of powder after leviation. According to in this method, according to density of particles, we separate the coarse powder and fine powders. We know coarse powder having high density and fine powders having a low density. Let's see working. The dry powder or paste made by leviation process is kept in an illustrating tank and mixed with a large quantity of water. The solid particles are uniformly distributed in the liquid by stirring and then it is allowed to settle down. Depending on the density of solid particles, it will either settle down or remain suspended in water. The sample is withdrawn at different heights through the outlets. These are dried and thus the powder with various size patches are collected. Friends, in what's illustration means with the help of water we mix our sample in our solid sample contains very either fine particles or coarse particle. If our large substance having a small particles, that means fine particles, they having very low density, they are movable in water but not settle down because of their low density. And if our particles having high density, that means coarse particle, they settle down by their density. Nowadays, in illustration process, the particles are suspended in a moving fluid, generally water or air. The apparatus consists of a vertical column with an inlet near the bottom for suspension, an outlet at the base for coarse particles, and an overflow near the top for fluid and fine particles. One column will give a single separation into two fractions. If more than one fraction is required, a number of tubes of increasing area of cross section can be connected in series. The velocity of the fluid decreases in succeeding tubes as the area of cross section increases, thus giving a number of fractions. These fractions are separated and dried. These are very simple illustration method. according to matlab with the help of density we separate out particles. Advantage about this illustration: the process is continuous. Depending on the number of fractions required, the same number of tubes of different area of cross section can be connected. The separation is quick as compared to other method of separation. The apparatus is more compact than as that used in sedimentation methods. A disadvantage: what's the disadvantage of illustration tank method? The separation of solid particles has to be diluted, which may not be desired in certain cases. Here is the diagram. Fluid and fine particles in upper side we get collect with the help of density. Coarse particle having large density, they are settled down. Illustration tank. Here is original diagram and here is our drawing diagram. In exam we need to draw this right hand side diagram. Only three names: fluid and fine particles outlet, upper side coarse particles, downside according to their density, and suspension of solids. Suspension of solids means our solid particles are mixed with the water or liquid media. Bag filter. Size separation of fine dust from the mill powder is achieved in two steps. In first step, the mill powder is passed through a bag filter, that means cloth, by applying the suction on the opposite side of feed entry. In the second step, pressure is applied in order to shake the bag so that the powder adhering to bag falls off, which is collected from the conical base. Construction: how bag filter is constructed. It consists of bags made of cotton or wool fabric. These are suspended in a sheet metal container. A bell crank lever arrangement is meant to bring the filter to normal atmospheric condition. Working: step first, feed is separated from air by passing it through cloth bags. Step 2, bags are shaken to collect the fines that are adhered to the bags. That means we pass our samples in bag. Some are attached to the adhere to the bags. These two steps are subsequent and are controlled at a different interval with the help of a bell crank lever arrangement. Filtering period. The exhaust fan position at the top keeps the bags under the less pressure than atmospheric pressure. The gas containing fine particles or dust enters the hopper and passes up. The gas feed passes through a fabric of bag. During this process, the fines are retained in the bags while gas reaches to the top of the casing. Because of air, the bag remains taut during filtration. Thank you, guys. You not need to bag filter study. We only main मतलब कि main separator used in this method is air separator, illustration tank method, cyclone separator, this like. So friends, if you're new on the channel, so please subscribe to our YouTube channel for pharmacy related videos like D Pharmacy first year, D Pharmacy second year, and B Pharmacy all years MCQs or some important topics we studied in this channel like a GPAT exam also. And thank you guys. We meet in next videos.